Hi everyone, I'm Drumil. Today I'm presenting VisionAssist, a real-time AI guide I built for visually impaired users. So moving on to the problem, over 295 million people worldwide live with moderate to severe visual impairment and 43 million are completely blind. The tools that exist today such as screen readers and braille displays help with digital content, but they do not do anything for the physical world. My brother is visually impaired and is an incoming CS student, and watching him navigate everyday tasks like finding his phone, reading a label, or walking into a new room is what motivated me to build this. Moving to the solution, uh, Vision Assist gives blind users three capabilities through a single always on app. First, a scene describer that automatically tells you what is around you every 60 seconds without you even asking. Second, an object finder where you say where are my keys and it locates you to tell where the direction is and the distances. Third, a text reader where you point the camera at anything and it reads it aloud. And all these three features run simultaneously in the background. Moving to the tech stack I built, this under the hood, the system uses four models working together. Gemini 2.5 flashlight is the brain. It understands the scene and holds a full conversation. OpenClip handles zero shot object localization, meaning it can find any object you describe without any training data. Depth Anything V2 estimates how far any things are from a single camera, and Easy OCR reads any text in the frame. The key point is that this requires zero fine tuning and it runs entirely on my MacBook and it costs me nothing. Moving to the live demo of how I'm conversing it, the flow goes on like this. The camera streams continuously. Gemini analyzes the scene and speaks a description aloud. When the user asks a question by voice or by typing, the AI responds conversationally with spatial language. You can see here in the conversation panel that I asked what action should I take to access my phone, and it responded by saying just reach forward a bit and your hand should be right on it. It remembers the full conversation, so follow up questions work very naturally. Moving on to the object finder of my live results. Here you can see the object finder in action across three examples. I typed umbrella and it found it in the bottom right. I held upon a phone and it detected it in the top right. And I held up a cap and it placed it in the middle right. So, which was a few meters away. The green bounding box is drawn directly on the live camera feed in real time using OpenClip zero shot localization combined with Depth Anything V2 for distance estimation. For evaluation, I tested all four components. OCR hit 91.4% accuracy. The object localization achieved 75% of correct quadrant accuracy compared to an 11% random baseline across 9 grid quadrants. Scene descriptions were spatially accurate and actionable in 13 out of 15 test cases. The full end to end response from speaking a question to hearing the answer averaged 2.6 seconds. Moving forward, moving to the impact and future work, I tested the app with my brother informally and he described it as a genuinely useful, specifically praising the proactive descriptions that tell him around about his surroundings without him having to ask. The app is fully offline after setup, so there is no privacy concern. It is deployed publicly on Streamlit Cloud, so anyone can access it from a browser at zero cost. For future work, I would like to run a formal user study, integrate grounding dyno for pixel level localization, and fine tune a model specifically for indoor house environments. Uh, so, Vision Assist started as a course project, but it is something I genuinely intend to keep building. The core idea is simple: independence should not require eyesight, and modern AI makes that possible today. Thank you so much.